An authority having jurisdiction AHJ may be justified in allowing a foot or less of unbonded water pipe under certain conditions. The primary consideration is whether the short section of pipe is unlikely to become energized. If the unbonded portion of the pipe is less than 1 foot in length and the pipe is located within a protective enclosure, such as insulated tape or hard insulating covering, that makes it highly unlikely to be energized, then it could be considered acceptable. Mitigation measures can improve the safety and likelihood of approval. Thick layers of insulating tape, such as electrical tape, can provide a high degree of resistance to accidental contact. Rigid insulating materials, such as polyvinyl chloride or PVC pipe or plastic sleeves, can provide a more permanent and robust barrier. The addition of a second ground rod outside enhances the grounding system and reduces the likelihood of fault currents flowing through the water pipe. The AHJ should ensure that all bonding requirements are met within 5 feet of the water pipe entrance. The unbonded portion of the pipe should be clearly labeled to indicate that it is not grounded. Signage or other appropriate measures should be taken to prevent accidental contact or use of the unbonded pipe as a grounding conductor. Ultimately, the decision of whether or not to allow an unbonded section of water pipe is at the discretion of the AHJ. The AHJ should consider all relevant factors, including the specific conditions at the installation site, the potential risks, and the effectiveness of the mitigation measures implemented. It is important to consider these measures. Firstly, ensure the unbonded portion is truly less than 1 foot. Measure it precisely. Secondly, select appropriate insulating materials. Use electrical tape listed for the purpose applied in multiple overlapping layers. For rigid coverings, ensure they are securely fastened and cover the entire unbonded section. Thirdly, verify the effectiveness of the additional ground rod. Measure the ground resistance to ensure it meets code requirements, typically 25 ohms or less. Fourthly, clearly label the unbonded section with a permanent warning tag or label. Fifthly, document all these measures, including photos and measurements, to present to the AHJ. Regarding the neutral current in the water pipe, the situation often arises from an imbalance in the electrical system. Neutral current should ideally return to the source via the neutral conductor, but if the neutral conductor has high impedance or is interrupted, the current may find alternative paths, such as through grounding conductors and metallic water pipes. To address this issue, one could consider the following options. Firstly, investigate the electrical panel and wiring to ensure all neutral connections are tight and properly made. Look for any loose connections or signs of corrosion. Secondly, check for any overloaded circuits or improperly wired equipment that may be causing an imbalance in the neutral current. Use an ammeter to measure the current on each phase and the neutral conductor. Thirdly, consider using a ground fault circuit interrupter, or GFCI, on circuits that are likely to cause ground faults, such as those serving wet locations or outdoor equipment. Fourthly, if the neutral current is still a concern, one could consult with a qualified electrician to evaluate the grounding system and make recommendations for improvement. This may involve adding additional grounding electrodes or upgrading the neutral conductor. As a reminder, any electrical work should be performed by a qualified electrician in accordance with all applicable codes and regulations. The grounding and bonding requirements are outlined in Article 250 of the National Electrical Code, or NEC. Section 250.4. A5 covers grounding of service-supplied alternating current, or AC, systems. Section 250.50 covers grounding electrode systems. Section 250.52 covers grounding electrodes. Section 250.64 covers grounding electrode conductor installation. Section 250.104 covers bonding of piping systems and exposed structural metal. Section 250.166 covers sizing the grounding electrode conductor for alternating current systems. A grounding electrode conductor connects the grounding electrode to the equipment grounding conductor, the service equipment enclosure, and the grounded conductor if present. The size of the grounding electrode conductor is based on the size of the service entrance conductors, as specified in Table 250.66 of the NEC. The grounding electrode conductor must be large enough to safely carry fault current back to the source. Bonding ensures that all metallic parts of an electrical system are at the same electrical potential. This reduces the risk of electric shock and provides a low impedance path for fault current to flow back to the source, tripping the circuit breaker or fuse. Bonding is required for all metal enclosures, raceways, and equipment. Bonding jumpers are used to connect metal parts together. The size of the bonding jumpers is based on the size of the circuit conductors, as specified in Table 250.102, C1 of the NEC. The water pipe bonding connection is required to be made within 5 feet of the point where the water pipe enters the building. This ensures that the entire water piping system is bonded to the grounding system. The size of the water pipe bonding jumper is based on the size of the service entrance conductors, as specified in Table 250.66 of the NEC. The bonding jumper must be large enough to safely carry fault current. In the scenario you presented, the plastic spacer or dielectric union effectively isolates the water piping system electrically. This prevents the water pipe from being used as a path for neutral current. However, it also eliminates the grounding path for the water piping system. To address this, the NEC requires that a bonding jumper be installed around the plastic spacer or dielectric union. This bonding jumper provides a path for fault current to flow around the isolated section of pipe. The size of the bonding jumper is based on the size of the service entrance conductors, as specified in Table 250.66 of the NEC. The bonding jumper must be large enough to safely carry fault current. It is important to note that the plastic spacer or dielectric union should be installed in a location where it is protected from physical damage. The bonding jumper should also be installed in a way that it is protected from physical damage. The addition of a second ground rod outside can help to improve the overall grounding system. However, it is important to ensure that the ground rod is properly installed and connected to the grounding system. The ground rod should be driven into the ground to a depth of at least 8 feet. The ground rod should be connected to the grounding system using a grounding electrode conductor. The size of the grounding electrode conductor is based on the size of the service entrance conductors, as specified in Table 250.66 of the NEC. It is important to consult with a qualified electrician to ensure that the grounding system is properly designed and installed. The electrician can perform a ground resistance test to verify the effectiveness of the grounding system. The ground resistance should be 25 ohms or less. If the ground resistance is greater than 25 ohms, additional grounding electrodes may be required. It is also important to ensure that all electrical equipment is properly grounded. This includes appliances, lighting fixtures, and other electrical devices. Grounding helps to protect people from electric shock and reduces the risk of fire. In summary, addressing neutral current issues and ensuring proper grounding and bonding requires a thorough understanding of the NEC and best practices. Consulting with a qualified electrician is essential to ensure safety and compliance. The key considerations are firstly, identifying and correcting the source of the neutral current. Secondly, ensuring that all grounding and bonding connections are properly made and sized. Thirdly, verifying the effectiveness of the grounding system with a ground resistance test. Fourthly, protecting the plastic spacer or dielectric union from physical damage. Fifthly, labeling the unbonded section of pipe to prevent accidental contact. Remember, electrical work can be dangerous. Always consult with a qualified electrician before performing any electrical work. Always follow all applicable codes and regulations. Always use proper safety precautions. Additional details can be found in the 2023 National Electrical Code Handbook.